So right here we have our magnetic reed switch sensor, and basically what this sensor does is that it can detect if there is a magnetic field around it. Here we have it connected to the Arduino Uno board to pins ground, 5 volts, and pin 2. Then on my laptop I have the Arduino IDE program running, and basically what this program does is that it can detect if there is a magnetic field close to the sensor or not, and it gives us a digital output of either high or low. So let's take a look at how this program works. Right here we are holding up this sensor and we are going to bring the magnet close to it, and you can see in the serial monitor what the state is. So when we bring it close, you can see how it turns into a high digital output. When we bring it apart, it goes to low. Once again, high and then low. So it basically gives us these two states, and in the next part of the video we are going to go over why this happens.
Hey everyone, and welcome back to Knowledge on Ears. And in today's video, we will be looking at a new exciting sensor called the reed switch sensor, also known as the KY025 sensor. And basically what this sensor can do is that it can detect if there is a magnetic field around it. That's pretty cool. And even though it's very simple, the mechanisms and structures inside of the sensor are pretty cool. And later on in this video, we will be going over those structures. But first, we are going to be taking a look at a pretty fundamental concept for this video, something known as ferromagnetism. So right here we have a magnet, and it's a pretty strong magnet. And over here we have an iron screw. And the special thing about iron screws is that just like nickel and cobalt and other materials like that, all those materials are ferromagnetic, which means that they can exhibit these very strong magnetic properties, and they actually get attracted to magnets. So if a magnet comes into contact with a ferromagnetic material, it can make it magnetic. It can make it like a magnet, and it can magnetize it. So right now, this is a ferromagnetic material that is not magnetized yet. So it has no magnetic properties so far that it is exhibiting. So if I try to attract this paperclip, it's not working. But since this is a ferromagnetic material, if it comes into contact with a magnet, then we can actually magnetize it and make it into a magnet. So let's come into contact, and instantly you can see it is attracted to the magnet, because ferromagnetic materials have magnetic properties. So now I'm magnetizing the screw, and now if I try to attract the paperclip, you can see that it gets attracted. It's not that strong, but it still has this attraction to it. And this attraction is a temporary attraction, so it does not stay for that long. So now we are going to dive straight into the entire mechanism and the structure of this sensor. So right here we have our reed switch sensor. But how is it able to even detect when there is a magnetic field around it? How does it even work? Well, it's all inside this glass tube right here. This tube acts as a switch. Right here we have an enlargement of the tube with all the parts inside of it. So we have these two reeds, and we have inert gas inside of this tube. Inert gas is basically another word for noble gas. And the cool thing about inert gas is that it's non-reactive. So it doesn't react with anything. So it makes sure that these reeds don't start to oxidize or nothing bad happens inside of this chamber. Then we have a gap in between these two reeds, and this gap is super important. But the special thing about these two reeds is that they are ferromagnetic. Yes, we looked at ferromagnetism earlier. And so when we had our iron screw, when we brought a magnet close to it, it got magnetized. That's the same thing that happens here. These ferromagnetic materials, so when there's no magnetic field close to it, then they are normal, and there's a gap between them. No current can pass through. It's an open circuit. It's an open switch. But when a magnetic field comes close to it, like a magnet or something, then it starts to magnetize both of these reeds. And we already know earlier, when we magnetized the screw, it was able to attract the paperclip. It's the same thing. When we magnetize these reeds, they attract each other. And what happens then is that they start conducting the circuit. Then current can start to flow through it, and it creates a closed circuit. And then once the magnetic field moves away, then the connection gets broken again and there's a gap again. So it's temporary magnetism when the magnetic field comes closer. So that's basically how it works. It's super cool and very simple, and it has this switch based off of ferromagnetism inside of it. But if you look closely right here, what happens is that there are these 4 pins. There is the analog output pin, ground, power, and digital output. And we already know what ground and power is. But we have 2 pins, analog output and digital output. We normally only use analog output when we are trying to get an output of the strength of the magnetic field instead of just if there is a magnetic field or not a magnetic field. And we know the digital output it just tells us 2 states. If the reeds are closed and there is a magnetic field, or if the reeds are open and there is no magnetic field. But we normally use the digital output pin, and that's also what we used in our earlier program in the video. And so what happens is that, let's just say there is a magnetic field, current can pass through, and it gives us a signal of high. It gives us a high signal. And when there is no magnetic field, current doesn't even pass at all, so it gives us a low signal. So that's how it works. It's pretty simple. It's actually a very simple concept, but it has these small mechanisms that actually come together to make it work. So thank you for listening. I hope you enjoyed it. Bye!